Today we're going to talk about how to graph an ellipse. An ellipse can be thought of as a circle which is elongated in one direction, or you can think of it as an oval. There are several parts to an ellipse. The center of the ellipse, right here or right here, have the coordinates HK. We have two vertices, which would be here and here, or here and here, and those are the endpoints of the major axis. Your major axis is the longest line segment that connects the two vertices. So sometimes the longest line segment can be horizontal, and sometimes it can be vertical. And then the other line segment going in the other direction, that's your minor axis. The equation of an ellipse in standard form is x minus h squared over a squared plus y minus k squared over b squared equals 1. Again, where h and k represent the center, a is the horizontal distance from the center, and b is the vertical distance from the center. So instead of trying to remember that a is the horizontal distance, just know that A is going to tell us how far to go on our x-axis. B is going to tell us how far to go on our y-axis. Now, when we pull out the center, which is our H and our K, if you'll remember, the standard equation of a circle is this part right here, where this would be r squared. So remember, whenever we were graphing a circle, when we pulled out the center of the circle, we had to change the signs of those numbers that were the coordinates of the center of the circle, because these signs are negative. So that negative sign changes our signs, because, for example, if I had, this is x minus h squared, if I were to plug in a negative 3 for h, that would be x minus negative 3 squared. Well, a negative 3 would be x plus 3. But I had plugged in a negative 3. So when I pull it out, my h is going to be a negative 3, not a positive 3, even though it looks positive in the equation. So just remember, just like the circle, when we're dealing with an ellipse, when we pull out h and k, we have to change the signs. And remember that a is our direction on the x-axis, b is the direction on the y-axis. So let's try graphing an ellipse. The steps for graphing an ellipse are, first of all, the equation must be in standard form. Then we want to pull the center out of the equation and plot the center. Then we will go the distance of a, which is the square root of whatever the denominator is of that first term, and we're going to move on the x-axis left and right horizontally and plot those vertices. And then we're going to do the same thing up and down for our vertical distance. Okay, so the coordinates of the center of this equation, do you see anything that's being added or subtracted from x and y? No. So that means that our center is going to be 0, 0. All right, so I'm going to plot that for my center point, 0, 0. Okay, and then a is going to be whatever the square root of this term is. So the square root of 4 would be 2. So that means, remember, that's underneath my x. So on my x, I'm going to go left and right 2 spaces. Okay, now since that's the smallest number, we know that's going to be the minor axis. All right, and so my distance for a is 2. The distance for b, here's my b, or that's the b squared. So I have to take the square root of that, and b is going to be 5. Okay, so B is 5. So on my y-axis, I'm going to go up 5 and down 5. And then I connect those points on the outside for my ellipse. Okay, so the length of the major axis, the biggest axis, is going to be, well, we went up 5 and down 5. So the length of the axis is going to be 10 units. The length of the minor axis, we went 2 spaces this way and 2 spaces this way. So the length of the minor axis is 4. The coordinates of the x-intercept, okay, so the x-intercept is where it crosses the x-axis. So it would be this point, which would be -2, 0, and this point, which would be 2, 0. And the coordinates of the y-intercept, if I go up here to the top, the coordinates of that point is going to be 0, 5, and then this point down here at the bottom would be 0, -5. All right, this ellipse does have something with our x and our y. Okay, so when we look at that, for the coordinates of my center, my h and my k are going to be what's in the parentheses. And remember, we have to change the sign. So my h is going to be +3, and my k is going to be -1. So hk is 3, -1. So let's go ahead and plot that point on the graph. 3, -1 would be right there. Okay, and then a is whatever's underneath my, or the denominator of my first term. A squared is the denominator of my first term. So I need to take the square root, which would be 3. Okay, so a is 3, and that's under my x term. So on my x-axis, I'm going to go left 3 from the center and right 3. Okay, then for b, that's the square root of my second term. The square root of 1 is just 1. So from my center, I'm going to go up 1 and down 1. And then I can connect those to make my ellipse. The length of my major axis, the biggest axis, since my a was 3, the length of my major axis is going to be double that, so it's 6. The length of my minor axis would be 2. The coordinates of my x-intercept, I only have one x-intercept. It's only crossing the x-axis right here at this point. And the coordinates of that point are 3, 0. And then my y-intercept, I only have one y-intercept, which is right here. And the coordinates of that is 0, -1. And that's how we graph an ellipse.